Okay, first and foremost, I want to make sure you remember that we have a quiz this Friday. The date is 5/14, so don't forget about that. Next, we're being told that we need to simplify these and state all the asymptotes. You don't have to necessarily state the domain like I did last class, but just as long as you state the horizontal and vertical asymptotes. So right off the bat, I see that my degrees are equal. So that tells me what my horizontal asymptote is. And that kind of looked like AA. Let me fix that. The horizontal asymptote is y equals, and it's 2 over 2. We look at those leading coefficients. So 2 over 2 is the same as y equals 1. Okay, so I'm actually going to factor out a 2 because it's common. 13 and 42. And in the bottom, I'm also going to factor out a 2 because it's common on all of those as well. So plus 6x minus 14. Okay, now what I get to do is go ahead and break this numerator down into smaller factors. So I need two things that can multiply to 42 and they can add up to 13. And that's going to get me a 6 and a 7 basically. So x plus 6 and x plus 7. Okay, and I'm going to do the same with the bottom, except for the fact that I'm going to fix my mistake that I made up here. I didn't factor a 2 out of that 14. So that should actually be a 7. So here we've got 2 and multiplies to negative 7, adds up to 6. So I'm thinking that's x plus 7 and x minus 1. Okay, so the vertical asymptotes are going to happen after we simplify. If you wanted to pull out the domain, this would be the stage you would do it. But let's go ahead and simplify. And we've got 2 times x plus 6 over 2 times x minus 1. So the vertical asymptote comes from the denominator here, and it says that x equals positive 1. Okay, now for our second one here, there is not a common factor in the top or the bottom. I do notice that my degrees are the same, so that gives me my horizontal asymptote of y equals 1 over 1, which is just 1. Okay, so I'm going to factor the top. I need two things that multiply to 4 and also add to 4. That's going to be x plus 2. It's actually a perfect square trinomial. So we'll put a squared on that. And the bottom is the difference of two perfect squares. So that becomes the square root of x is x. One time we get a plus, and one time we get a minus. The square root of 4 is 2. Okay, and then I can cancel out an x plus 2 in the denominator, and one of the x plus 2's in the numerator. So that leaves me with x plus 2 in the numerator and x minus 2 in the denominator. And from that we can get the vertical asymptote, which is x equals positive 2. Okay. So what we're going to do next, the objective for today, is that we're going to be creating rational equations with one variable so that we can use them to solve problems. This is the application lesson, basically. Okay. So here's our first setup. Okay. Take a second, read through it, hit pause, read through it, and see if anything stands out, if you know, what you might think you do on it, all of that. So it's not going to do you any good just to follow along with me. Try and do some thinking about it before I go over the solution. Okay, so right now, Anne and Marie, they play tennis, and Anne has won 12 out of the 20 matches. So right now, that's her winning percentage, which is 12 out of 20. So it's 60% right now. If I did that division, I would see that it's 60%. But we want to see how many matches Anne has to win in a row to improve her skill, her winning percentage to 75%. Now the thing here to think about is the fact that we want her to play more matches, but win all of the matches, basically. So instead of just 12, we're going to add on all of the additional matches that she plays. And we're also going to add that same number to the total matches. So basically, I'm going to say that, like say, if she played 2 more matches and won them both, that would be 14 out of 22. We want this to equal 0.75. So now it's my job to go ahead and solve this. Okay, so I'm going to multiply both sides by the 20 plus m. So I get 12 plus m equals 0.75 times 20 plus m. And I'm going to go ahead and solve this. Okay, I'm running out of room here, so I'm going to go up here and solve it up here. So I'm going to leave the 12 plus m alone for right now. And I'm actually going to distribute the 0.75. So 0.75 times 20 is 15. And 0.75 times n is 0.75 m. Okay, so let's subtract 12 from both sides. It gets me 3. And let's go ahead and subtract 0.75 m from both sides. Okay. And this is 1/4, so I'm going to multiply both sides by 4, and it will get rid of that decimal there. So that would mean m equals 12. So what I'm saying is that she must play 12 more matches to get her percentage to 75%. Well, let's go over here and check what I just said. 12 plus the new number of matches, which is 12, over 20 plus the new matches, which is 12. So that's going to get us 24 over 32, and you can check it, that 24 divided by 32 gets us 0.75. Okay, so that worked out for us. In the second one, we're going to do the same process, only this time we want to raise her percentage to 90%. I'm going to predict that the number of matches is going to be much higher to get it to the 90%. So again, we're still using the 12 plus m over 20 plus m, but instead of equals 0.75, we're going to say that equals 0.9. So I'll multiply both sides by this denominator. In other words, 12 plus m equals 0.9 times 20 plus m. Again, I'm running out of room, so I'm going to go up here. And I'm going to actually distribute that 0.9. And I'm going to get, well, the one side stays the same. 0.9 times 20 is 18 plus 0.9m. So I'm going to subtract 12 from both sides. So m equals 6 plus 0.9m. I'm going to subtract 0.9 from both sides, 0.9m. That gets me 0.1m equals 6. And that's the same as 1/10. So I'm actually going to multiply both sides by 10 to get rid of it. So 60. She would have to play 60 additional matches to get to 90%. Can she ever reach winning percentage of 100%? Well, let's go see if that even works out. Let's say we're going to take it from 12 plus m over 20 plus m. We'll make that equal to 1, because that would be 100%. So that's the question. Are you ever going to get there? Okay. So 12 plus m needs to equal 20 plus m, because I just took that and multiplied it by the 1. So now when I go to solve this from this point, I'm going to subtract 12 from both sides. So that gets me m equals 8 plus m. Now I'm going to subtract m from both sides. And I get this really wackadoo statement that 0 equals 8. Okay? Well, basically what that's telling me is no, she can never reach 100%. And it's because she's already lost 8 games here in the beginning. Okay? She could get close to 100% with the more games she wins, but she can never reach it. And so we understand that concept as being an asymptote. So that's what she's looking at there. So after Anne has reached her winning percentage of 90% by winning consecutive matches in Part B, okay, how many matches can she now lose in a row to have a winning percentage? Well, if we're losing, right, in a row, that means that we would be subtracting from it. So I'm going to go from that original rational function. I'm going to say, okay, her original amount was 12, and we know what the m is for the 90% that it's setting up for. It's 60, so we'll add 60 to that. But now we want to subtract the number of matches she's losing. Same with the 20. We'll add the 60, which is the m. And actually, let me change that variable because we already used that for the number of matches she was going to win. Let's put it as an L for losing. And we're going to subtract the number, the total number of games that she loses. We actually are adding that L. No, we're not actually adding anything to the top because that's the number of games she wins is going to stay the same. But what we're going to do is increase the total number of games played. She's just not going to win any of them. All right, so if I simplify this, I've got 72 over 80 plus L. Okay, so I want to make 72 over 80 plus L equal to 50%. So 72 over 80 plus L is going to equal 0.5. I'm going to go ahead and multiply both sides by this denominator, the 80 plus L. So 72 equals 0.5 times 80 plus L. Okay. So 72 should equal 40 plus the number of games in a row that she loses. So I'm going to solve that. I'll rewrite it. 72 equals 40 plus L. Subtract 40 from both sides. So she would have to lose 32 games in a row to get back down to 50% after she was already up at 90%. Okay, so we got another example to work through. It's in the guided notes. You could take a second and read the next example and try and work on it a little bit before you watch me go through it. Here's our second one. Oh, wait a second. I caught a mistake. I forgot to distribute this 0.5 to the L. So I'm missing something there. So let me fix that really quick for you. I don't want you to go with a mistake. So that's 0.5 L. So that makes a difference. So now we're looking at 72 plus 40, equals 40 plus 0.5 L. And now I'll subtract the 40, and that's where the 32 came in, but I thought I was done. But in fact, I'm not done. This was multiplying by 1/2, so I'm actually going to multiply both sides by 2. So I'm actually getting that she needs to lose 64 games in a row in order to get to 50% if she'd already been up at 90%. All right, now we'll go on to the next example here. Okay, so we have these 3 people and they're painting a room. Sam, Jenna, and Francisco take 2 hours to paint one room. Okay, so that's one room in 2 hours. So it will take Sam plus Jenna plus Francisco. They can do it one room in 2 hours. Okay, we're all going to set up our fractions the same way, rooms over hours. So when Sam works alone, he can paint one room. Here's Sam. He can paint one room in 6 hours. Okay, and when Jenna works alone, she can paint one room in 4 hours. So one room in 4 hours. But we don't know how long it would take Francisco to paint one room on his own. So one room in, I don't know, let's use F for Francisco, right? Lowercase f. Okay, we do know already that one room in 2 hours if they work together. So what I'm going to do is I'm going to find a least common multiple of this denominator and multiply every single fraction by it. So I need a number that 2, 4, and 6 all go into, and I'm going to put an F on it too. So hopefully you have identified that that should be 12F. I'm going to multiply every single term by 12F. So 12F over 6 plus 12F over 4 plus 12F over F will equal 12F over 2.
So now I can simplify my fractions, and it should be a much easier way to handle. So this simplifies. 12 over 6 simplifies to 2. 12 over 4 simplifies to 3. The f's on this one would cancel out. And 12 over 2 would be 6. Now what I'm going to do is I'm going to get all of my like terms together. So I've got 6f here that I'm subtracting 3f from. And then I've got the 2f that I'm going to subtract from both sides. So it looks like Francisco would take 12 hours to paint one room. And that answers our question. Question: determine how long it would take Francisco to paint the room on his own. 12 hours. He works pretty slow. Okay, but these were rational expressions that I was working with. That's what relates to what we're doing. So let's look at the next example here. Take a second to read it, and then I'll go over some. All right, so we have Melissa walking to a friend's house, and then she's riding her bike home from the friend's house. And what we do know, we don't know how fast she walks, but we do know that when she's on the bike, she's going 4 miles an hour faster than when she was walking. And we also know that the total time to her friend's house and back is 2 hours. So we're going to make the trip, the walking trip plus the bicycle trip is going to equal 2 hours. So the other thing we need to know is this relationship that you probably picked up in another science class. Distance equals our rate times the time. So if I was trying to figure out maybe how far I'd driven, I would take my speed and I would multiply it by how long I was driving that much, and that would tell me how far I went. But we can rearrange this formula so that we can figure out what the rate actually is or what the time actually is. Okay, so that's really what I'm wondering is the time, because it's been 2 hours. So I'm going to say the time is going to equal the distance she traveled over her rate. Now we don't know the rate in this case, but we're going to get to that point. Okay, so for her walking, we know that she went a distance of 3 miles and at some rate. And for the biking, she went that same distance of 3 miles. Okay. But all we know about her speed for that one was that it was 4 miles an hour faster. So that would be the rate plus 4. And that whole thing should equal 2. So what I'm going to do is I'm going to work to get a common multiple in my denominator so that I can actually add these things together. Okay, so I'm going to multiply this fraction by the piece of the denominator I'm missing, which is r plus 4 over r plus 4. And I'm going to multiply this thing by the piece of the denominator I'm missing, which is r over r. Now, these things are equal to 1, so I'm not changing the value anything by doing this. I'm just writing it kind of in an unsimplified form. So when I do this multiplication, I get 3r plus 12 over r squared plus 4r plus 3r over r squared plus 4r. And that should equal 2. So now that I have like denominators, I can actually add my numerators together. And I'm getting 6r plus 12 over r squared plus 4r. And that equals 2. So now I can multiply both sides by the denominator. Get left over here with the numerator. So that's going to be 2r squared plus 8r. I just took this and multiplied it by 2. So now I'm going to try and get everything over to one side of my equation, get it set equal to 0 so I can factor it and find out what my rates could be. So I'm going to have it equal to 0. 2r squared is still there, but I'm going to subtract 6r from the 8r. That's still plus 2r. And then I'm going to subtract 12 from the whole thing. So I'm going to have minus 12. Well, I don't know if you see it yet, but there is a common factor in all of this. So let's go ahead and factor that out. So we have r squared plus r minus 6. And then I can factor that trinomial. Leave the 2 there. So I need something that multiplies to -6 and adds to +1. So I'm thinking that's going to be R plus 3 and R minus 2. Okay. So if I read what the zeros are in this factored form, I get R is equal to -3 or +2. Now, we're talking about rate. We're talking about a speed here. So I know it's not the -3. I'm not going to go a speed of -3. So that means she is walking. Her rate is 2 miles per hour. So that's her walking rate. And remember, to get her biking rate, we would have to add 4. So the biking rate would be at 6 miles an hour. But it didn't ask me for that. It only asked me for her walking rate. All right. Now let's take a look at the next problem. So I read through the problem, and I noticed this was a lot like the first problem we did when we were talking about the number of games, the 12 out of 20 games, and we were changing the percentages there. So it's a lot like that. So right now I know that the percentage of juice she has is 60%. Well, 60% of my 10 liters is 6. So that's telling me that my current rate in my juice is 6 to 10. Okay? And the 6 is the pure juice and the 10 is the total liquid. Okay? So we want to know how many liters of pure juice need to be added to get it to 75%. So my pure juice is the numerator. So I'm going to say, okay, let's add, I don't know, J for juice. But I'm going to add it to the total amount also, right? And I want to get that to 0.75. So this is very reminiscent of that last problem we did about the games. So I'm going to multiply both sides by this 10 plus J. So I'm going to get 6 plus the juice I'm adding is equal to 7.5 plus 7.5J. I'm going to subtract 6 from both sides. So J is equal to 1.5 plus 7.5J. I don't know why they came on. Oops. I don't know why I did that. I changed from 0.75 to 7.5. I got to go back and fix that. It was 7.5 there because I multiplied by 10, but this should have stayed at 0.75J. There we go. Okay, so now I'm going to actually subtract the 0.75J from both sides, and that gets me 0.25J equals 1.5. So now I'm going to do that division. I'm going to do 1.5 divided by 0.25. Oh, I believe that's 6. So I'm pretty sure we should be adding 6 liters. So we have 6 liters of pure juice. Okay. We're going to do the same thing here. We want to know how much pure juice needs to be added to make the blend 90%. So I'm still using the 6 plus J over the 10 plus J. Only this time I need it to equal 0.9. So I'm going to multiply both sides by 0.9 by 10 plus J. So that gets me 6 plus J equals 9 plus 0.9J. We'll subtract 6 from both sides. And I'm going to subtract 0.9 from both sides. So that actually gets me up over here. This one up over here. So when I subtract 0.9 from both sides, I get 0.1J equals 3. So that's 1/10. So I'm going to multiply both sides by 10. And J should equal 30. In order to get my concentration in 90%, I need to add 30 pure juice. Okay, we're going to write an equation that relates the desired percentage P to the amount A of pure juice. They want us to use A for the
pure juice instead of our J, that needs to be added to make that the blend that is P percentage. Okay, and then what's a reasonable restriction on that set of possible P's. So part C is asking us to kind of write a general equation for us to use P as the percentage, as the desired percentage, and we're going to use A as the juice, so instead of the J. So I'm thinking it's going to look like this: 6 plus the juice that we add over 10 plus the juice that we add is going to equal, and percentages are out of 100, so I'm going to do P out of 100. Okay, and I need to think of a reasonable domain for this. Well, I can't add, for P that is, I can't go below 60% because I'm already starting at 60%. So I'm going to say 60 is going to be that smallest value. And for the percentage, I can't have more than 100% of juice, so it's going to be less than 100. So that's my reasonable restriction on my domain there. And the next problem says, what if we go ahead and add 15 liters of juice? Okay, what's the percentage of juice then? Well, this is now my A value. So I'm going to do 6 plus 15 over 10 plus 15. And that's going to equal some number over 100, my percentage basically. So we have 21. 6 plus 15 is 21. And 10 plus 15 is 25. Okay, and that equals P over 100. So I cross multiply here. I have 2100 equals 25P. So then I'll just take 2100 and divide by 25. And find out what that P is. So 2100 divided by 25 is actually 84. So it would be 84% if they added 15. So part C, it actually wants us to solve this equation up here, okay, and get A by itself. Okay, so I'm going to need a little more room. I'm going to go ahead and shrink this so I have space underneath, okay. There we go. All right. So looking at that equation, I'm going to do it up here to make sure I have space. 6 plus A over 10 plus A needs to equal P over 100. So what I'm going to do is cross multiply. So I'm going to do 100 times the 6 plus A, and then P times the 10 plus A. So I'll go ahead and distribute that 100. 600 plus 100A, and I'll distribute the P. So 10P plus AP. Now what I want to do is I want to get all of my A's to one side and then everything else to the other. So I'm going to bring this AP over here, and I'm going to take the 600 over the other side. So that means I've got 100 minus A. Oops, I forgot my A on that one. 100A minus AP equals 10P stays where it is, but I bring the 600 over there, so it's minus 600. Now what I have is I have an A in both of these, which I'm allowed to factor out. And that leaves me with 100 minus P, which is 10P minus 600, and then I'll divide both sides by that factor, and that will give me A all by itself. So 10P minus 600 over 100 minus P. So this way I have written the equation in terms of A, okay, so that it is solved for A. And the last part of the question says, are there any excluded values of P? Yeah, from this I can't have P equal to 100 because that would make the denominator 0. And does that make sense? Yes, it makes sense. We can never actually reach 100% because we're starting with already 6/10. We're starting with that diluted amount, just like the girl couldn't end up with a gain percentage of 100% because you'd already lost some in the beginning. All right, let's check out another. So we're talking about 10% acid and 30% acid. Okay, and we're going to create a how much of the 30% solution must you add to 1 liter of the 10% solution to create a mixture that is 22%. All right, so I'm sorry, I need to clear this page. There we go. Try this. So we have a solution containing 10% and another solution containing 30% acid. The one containing 10% is 1 liter, and we don't know how much the one containing 30% has in it. So we have 0.1 times the 1 liter plus the 0.3 times we don't know over the total amount, which is the 1 liter we already have plus the amount we're adding of the 30% solution. And that whole thing's going to equal 22%. So we put 0.22. So when I simplify this, I get, well, that's just 0.1 plus 0.3a equals, and I'm going to multiply this side by the denominator. So it's 0.22 plus 0.22a, because I'm going to distribute that to both pieces. So then I'm going to bring it up here, and I'm going to get the a's all on one side and everything else all on the other side. So what I'm going to do is subtract 0.1 from both sides. So that gets me 0.12 plus 0.22a and 0.3a. Now I need to subtract 0.22a from both sides, and I believe that gets me 0.08a equals 0.12. Then I'm going to divide both sides by that 0.08 to get what a is. So I'm doing 0.12 divided by 0.08, and that's getting me 1.5. So I need to add 1.5 of this solution to 1 liter of this solution to get a concentration of 0.22. So we're going to write that like we did the last time. We're going to write the expression and then figure out what a reasonable domain would be for that. So my expression is, I'm just going to go with the 1 here and do the multiplication. So 0.1 plus 0.3a over 1 plus a is equal to 0.22. Actually, we need to change that, right? Because that's what it's saying. Equals the percentage over 100. That's what it's telling me to do. Now, the mixture is already at 22% before I do any addition, basically. Okay, so I know that. Okay, so I just brought this up. This is solving like we just did on the last problem. So I took my equation here and I cross-multiplied. Okay, so I did 100 times both of those things. That's what that says. And 1 plus a times the p. That's what that says. So then I distributed the 100 to both things here. I distributed the p to both things here. And then I took and found the a terms and got them all over to this side, and all the other terms, the minus 10 and the p, over to this side. I was able to factor out an a, left me with 30 minus p. And so then this is what my a equals. Now for part D, I'm actually going to use that formula I just came up with. So let me shrink this some. All right, so I'm going to use the formula I have to find, I already know what the percentage is. It says I want a 26% solution. So I'm trying to figure out how much I'm adding of the 30% solution. So A is going to equal the 26 minus 10 over the 30 minus 26. And now I could just put that percentage in instead of trying to go through all the rigmarole like the last time. So that's going to get me 16 over 4. Oh, so that means I should add 4 of the liters of the 30% solution to what I already have, the 1 liter of the 10%, and it would take me to a 26% acid solution. All right, so there's some example problems there. You have
some closure questions here, kind of like we just did. Go ahead and do those. Okay, remember we do have a quiz this Friday as your assignment, so make sure you're going on to do that when you can. You have 2 attempts at it like we're used to. Okay, just get that done as soon as you can, so that because we won't have much time for you to make stuff up we're coming to the end of the school year. Okay, so don't fall behind right now. We need every last day that we have to get grades done. Okay. All right, so go ahead and do your closure, and then the next thing you're going to do on Friday is the quiz. It's probably already open if you wanted to give it a shot now. And then there'll be another lesson next week. Your test won't be coming up until the 26th.